All right, let's finish this up. It's 2/3 of the area of the base. So what is the base of this thing? It's a circle, right? So it's pi what? R squared times the height. Now, what did we just say about the height? Let's do it in, well, let's not even use the numbers. Let's just do it in terms of r, the radius. What would the height be in reference to the radius? Twice the radius. That's right. Okay, so the height would be what? 2 times the radius. Make sense? Now watch. It doesn't take that long. It's pretty easy. Let's multiply these together. 2/3 times 2. What is that? 4/3, right? Just multiply straight across. That's all it is. Okay, elementary math, right? And then it's pi. What about the r's? R squared times r, or r to the first. What's r squared? They cancel? They're multiplying. We're multiplying. We're not dividing. It's r cubed, right? R squared times r, which is r cubed. And that's your formula for volume of a sphere right there. If you want to memorize that, feel free. 4/3 pi r cubed. It's really not all that hard to memorize. But I like to show where it came from. This is where it came from right here, because the volume is 2/3 of the cylinder. The cylinder is the area of the base times the height. The base is a circle, pi r squared. The height is twice the radius. Take 2/3 of it, because that's the sphere. You multiply it all together, and you get that nice little pretty equation right there. Okay, 4/3 pi r cubed. Some people don't think that's very pretty. They don't like memorizing it, but it's not that hard to memorize. But if you don't have it memorized, just remember that 2/3. The sphere, remember this picture. That ball, that sphere, sits inside the cylinder, and it takes up how much? 2/3 of that whole entire cylinder. If you can remember that, you could always come up with this formula every single time. Okay? All right. Let's take this sphere and do this. It's on the top of 23. I'm not going to, well, I don't know. Maybe I will. Watch. If we take this sphere right here, and if I was to chop it, I'm not going to try to make this to scale or anything. What if I was to chop it right down the middle? Slice it right down the middle. Think of it. You got a big old grapefruit or some kind of a ball, right? And you slice it right down the center. And you open it up. You get 2 pieces, right? You look at one piece. What's it going to look like? Yeah, not just any flat surface. What? A circle, right? If you take a sphere, perfectly, round sphere, and you cut it right down the middle, you open it up and look at it, you get a nice pretty circle, don't you? Well, if I wanted to wrap something around this sphere, I wanted to find the surface area of this sphere. It actually takes 4 of these to wrap perfectly around that sphere, around the outside of it, okay? So I cut it down the middle, all right? And basically, it makes a circle. It makes the same circle as what the base would be, doesn't it? All right, so if I cut this straight down the middle, I'm going to get a circle that's exactly the same size as this circle right here. So if I wanted to find the area, the surface area of this whole entire thing, it takes exactly 4 of these to make the surface area of that particular sphere, okay, with that particular radius. So if the radius of this was 5, guess what the radii of all 4 of these are going to be? They're going to be 5. So really, all you got to do is just find the area of one of the circles and then do what to it? Multiply it by 4. Okay, or if you wanted to, you could do this. You could say the surface area of this sphere is just what? 4 pi r squared. And again, you can memorize that if you would like. It's pretty easy. Or if you forget it, you just remember those 4 circles right here. Okay, can you remember those 4 circles? If I cut this in half, those 4 circles will wrap around this whole entire sphere. Okay, so that's the surface area. Does it make sense? Now, it wouldn't be a very easy wrap, would it? Because you put one, you're going to have some overlapping, have some gaps, you're going to have to take them and cut them and all that. But if you're able to do that, and if you're able to cut it all out and make sure it all fits perfectly, exactly 4 of these will wrap perfectly around this entire sphere right here. I've never tried to do that, but I'm taking their word for it that that's true. All right? Does that make sense? Okay. Yeah, so the questions they have, there's a couple examples on there. If you want to look at those examples, it's pretty straightforward what we were just doing right here. So I'm not really going to go through the examples, but you can do that if you would like. All right, well, that's it. Let's do this. We got a few minutes, don't we? What is this, third period, 10:35? We got 5 minutes. Let's just take a few minutes. We got a few extra minutes on this YouTube thing. Let's hit maybe some of these problems that you weren't sure about? Daniel, you were looking at one, like number 9, weren't you? Didn't you say that that looked real crazy? Was it 8 or 9 or 6 or whatever? You were looking at some of those, weren't you? All right, let's take a look at number 6. Let's do this one. So I'm going to write it out. 5 squared, a cubed. Oops. That's a weird looking cubed. There we go. B to the negative second, a. And that's all over. So if you can do this one, that should help you out with 8 and 9. All right? Because it's just a basic principle here that we have to go over. 8 to the negative third, b squared, and b to the 0. It's just, man, my writing's awful. That's to the 0. Okay? So what we're going to do is we're going to simplify these things. Now, the regular number you should be able to do. That's not that big of a deal. 5 squared over 5. You could just multiply them out, but watch. Do you remember this rule back in the day? Like if I had that, do you remember what you do here? You subtract the exponents, right? Or this is what I do sometimes, especially if they're both positive. I say this means that there's 3 x's on the top. This means there's 2 on the bottom, right? So 2 of these cancels with what? 2 of these. How many do I have left over? Just 1, so it's just an x. Or you could go 3 minus 2, x to the first, either way. I kind of like to do this way, to tell you the truth.
Just be x still?
Yeah, just be x, okay? You follow me? Look at this. This is 5 to the second, 5 to the first. Well, one of these 5s goes with one of these 5s, so what are we left with? Just a 5. Make sense? Let's do this, though. Before we start canceling the other stuff out, look, I got a's on top here, and I got, what, b's on the bottom here. Let's simplify the top first, simplify the bottom first, and then we can mess with the stuff top and bottom, okay? Let's do the a's. A cubed times a to the what? First. If there's no number there, it's to the first. What is a cubed times a to the first? You add the exponents. It's on the top. They're both on the top. We're not canceling out. We're doing this one and this one, okay? So it's a to the what? Fourth. Good. So I'm done with that. And then we'll just leave this b to the second because there's nothing else on the top that I can do with that. Let's look at the bottom. You just have an a to the negative third. You only have one of the a's on the bottom. Look at this one. You could do this if you wanted to. B to the second times b to the 0. What do you do with the exponents? You add the exponents. What's 2 plus 0? It's just 2. So it's just what? B to the second. But what is b to the 0? B to the 0 is just a 1. It's not a 0. It's a 1. It's a 1. So really, that just goes away, doesn't it? So I'm left with b to the second either way you look at it. Now let's take a look at this. Now I can do this stuff that I was talking about. I got a's on top and bottom and b's on top and bottom. One thing we didn't talk about was this. What if I have like x to the negative fifth and x to the third? What if I had that? Well, it would be negative 5 minus 3 would be x to the negative 8th, wouldn't it? Or you could do this. Do you remember doing this? If you have a negative exponent, take it, flip it down to the bottom. Do you remember doing that? You don't remember doing that? Algebra 1, you didn't do that stuff? You should have done a ton of that in Algebra 2? No? Alright, we're learning it now. Watch. X to the negative fifth. If you have a negative exponent, it means you can flip it to the bottom. But if I flip it to the bottom, guess what I'm going to have to do to that negative? I'm going to have to change it to a positive. Okay? So that goes away. Well, what's left on top? Just nothing? Just a 0? No. A 1 is left on top. So now what would this be? It would be 1 over x to the what? 8th. Or I could do it another way. Watch. What if I had x to the negative fourth on the bottom and I had x to the negative second on the top? I could flip them both, couldn't I? Because they're both negatives. But watch. Let's just take this one, flip it to the top. If I flip it to the top, what do you think I'm going to do to that negative? I'm going to change it and make it a positive. It's the same exact thing. Now look what happens. I don't have to take this and move it to the bottom now, do I? Because when I add those exponents together, what am I going to get? I'm going to get a positive 2. Do you follow me? Is it coming back at all to you? So let's go back up to this. What am I going to do here? Am I going to move this down to the bottom, or am I going to move a to the negative third up to the top? Yeah, let's move this up to the top. So let's take this. If I move it up to the top, it's going to be a to the what? Positive 3. So it's getting a little messy. Hang on just a second. So it's going to be 5a to the what? 7th. And then look what we're going to do here. Which one are we going to move here? Move the negative second to the bottom. So this is going to be b to the what? Right? So it goes away here, and then on the bottom is b to the fourth, and that's how we do it. Now, if you can do that, that should help you with number 8, and it should help you with number 9. All right? So you got to learn those rules, and they just kind of assume that you already know how to do those because that's kind of an Algebra 1 principle. All right? So finish Lesson 2 by Tuesday. That is going to be due on Tuesday. Everybody got it? All right. Have a good weekend.